So look up now. Let me explain it very well. So this is a galvanometer. So now looking at this setting, the question says, read the question out real quick, please.
In the diagram above,
Okay.
the galvanometer indicates a null deflection.
A null deflection. Take the first word, null deflection.
Okay.
Deflection is a keyword there. Continue.
What is the potential difference between X and Y?
So what is the potential difference? What is the PD between what? X and Y. X and Y. And here I used they want the PD between Q and Y. The PD between Q and Y, that's the PD they want. The PD across this side. So from this X and Y, it's approximately, we take here as X, we take here as Y. But then you can say Q and Y. So looking at this stuff, a whetstone bridge, right? Now,
Yeah.
the PD across this side, there's a current that comes from here, right? That current, when it comes to this side, it shares. See this current going to, because these things now are not, they're not arranged in series. So the first current that goes here is I1. The second current that goes here is I2. Can you see it? So now, the same current that goes here will flow from here to this. Let's say this is R1, this is R2, this is R3, and this is R4, right?
Yeah.
Now, for us to get the PD across here, okay? The PD across here, there's a condition. They said a null deflection. In a null deflection, when you continue to move, because the resistors that you have here are all variable, right? You can move them and move them. There's a point where you will move the resistor, the 4 ohms resistor and the 3 ohms resistor. The galvanometer will no more indicate anything, right? At that point where the galvanometer is not indicating anything, it means that it's a null deflection. All the potential differences are equal, right?
Yeah.
The potential differences are equal at that point. So you will say that the potential difference across X arrow is the same as the potential difference across arrow Y. The potential difference across XQ is same as the potential difference across Q arrow. We did it. So PD across X, but we don't want to call here X. Let's call here Z, and call here W. So potential difference across ZW equals the potential difference across WY. PD across ZQ equals to PD across QY. Am I right? Coco, are you there?
Yeah.
All right. So that's the PD, right? That's for the PD. So PD, you know, V from Ohm's law equal to IR, right?
Yeah.
From Ohm's law. So taking it from this side, the potential difference across this, we are trying to prove, but I'm not going to prove for you. I don't want to prove again. If I prove, it's going to be long. But this is I1. The potential difference across Z and W will give you I1 R1 equal to the potential difference across W and Y will give you I1 R2. Are you seeing it? Then the potential difference across Z and Q will give you I2 R3. The potential difference about Q and Y will give you I2 arrow. That's that arrow that is unknown. That's our unknown arrow. That's it. Can you see it? Now, but because it's a null deflection, the PD across them is said to be what? Unknown for now. It is unknown. The PD across them is said to be unknown, but something is wrong. Because, you know, I told you this is variable resistors. Something is common. The current between them will be common because the galvanometer is no more producing any deflection. It's null. So since the galvanometer is null, the current flowing through them will be equal. That means I equal to I1 equal to I2. So I is the 2A that is present. I is 2A, right?
Yeah.
No, that means the current is common, 2A. Ampere, A is the ampere, so it's supposed to just be 2, right? So in this diagram, if you have something like, look very well, we have 2R1 equal to 2R2, those current equal to, then 2R3 equal to 2R. Just 2R, right? 2 will definitely cancel each other, right?
Yeah.
Now we'll now have something like this, R1 over R3. Sorry, no, not over R3. R1 equal to R2, then R3 equal to R4. This is not over yet. So this R4 is R. So we cross multiply. If we cross multiply, we will have R1 R equal to R3 R2, right?
Yeah.
So at this junction, something will happen. Something will really happen here. So now we know that R2 is what? What's R2? R2 is 2, R3 is 3. So R1 is 4. So what we have is 4, that's R equal to 3 times 2. Am I right?
Yeah.
So make R subject to formula. It will be, your answer will be, are you writing at all? Your answer will be R equal to 6 over 4, right?
Yeah.
They have a common factor, which is 2, 3 here over 2. So your answer is 3 over 2. We've gotten R to be 3 over 2. 3 over 2. Are we correct?
Yeah.
Now they say, what is the PD across here? Is it not simple? See the current flowing through them. The current flowing through all of them is still the same 2A. And then we use the current, we use the steady current to find, what did we find? We found the resistor here. R here is equal to what? 3 over 2, right?
Yeah.
So if you are looking for the PD, V is equal to I arrow from Ohm's law, what will we do? We use the common current, 2 times 3 over 2. So this will cancel this. What do we have? Your answer is the voltage between them is 3. So the voltage is 3. So how do you see it? Does it look good?
Yeah.
All right, Coco. We're done with that. I'll give you some other assignments. I'll give you some classwork.